Hi everyone, and welcome to the third video of the six-part series for the United Organization of Healthcare Professionals educational series. In this video, we will be building on the previous concepts and taking one step further. Let's talk about muscle tone. Muscle tone is the level of tension that is present in your muscles all the time. This includes even when you're resting, there is still muscle tone in your muscles. Muscle tone is controlled by the brain. The correct muscle tone is what helps you sit upright, keep your balance, and move feeling steady. So now let's look at how muscle tone works. If we bring back the reflex arc from the stretch reflex, we can add one more neuron into the mix. The gamma motor neuron. The gamma motor neuron connects to the muscle spindle. This might sound like it's about to get complicated, but let's go through this slowly. The gamma motor neuron controls the sensitivity of the stretch sensors that are located on the muscle spindles. You can think of gamma motor neurons as a sensitivity dial for the stretch sensors. They control how alert the stretch sensors are to muscle stretch. This is where it gets tricky, so stick with us. When gamma motor neurons are receiving electrical signals from the brain, the stretch sensors are only able to sense large stretch. When gamma motor neurons are not receiving electrical signals from the brain, the stretch sensors become more sensitive to stretch. So by default, the brain is telling the gamma motor neurons to relax the stretch sensors. Gamma motor neurons do not directly cause the muscle to contract like the alpha motor neurons. Instead, they change the sensitivity of the stretch sensors. So that when the muscle is stretched, the stretch sensor communicates that with an electrical signal to the spinal cord. At the spinal cord, the sensory neuron from the stretch sensor is telling the alpha motor neuron to contract the muscle more. This is very important because in spasticity, the muscles become more stiff than usual and contract more often. So this means that when the gamma motor neurons are not working properly, the stretch reflex stops working properly. So this means we need proper control of the gamma motor neurons so the stretch reflex working properly. So what controls the gamma motor neurons? Well, it is more neurons this time coming from the brain. Neurons from the brain are called upper motor neurons. This is going to be the most complex part of the video, but we will try to make it easy, so please try to stick with us. The electrical signal from the upper motor neurons is what controls the stretch reflex. Electrical signals from the upper motor neurons control the alpha motor neurons and the gamma motor neurons. 1. When upper motor neurons sending electrical signals to the alpha motor neurons, the muscle contracts. 2. When upper motor neurons are sending electrical signals to the gamma motor neurons, the stretch sensitivity decreases. When everything is working properly, the brain is able to send the correct electrical signals to the spinal cord, causing a voluntary and muscle contraction. The alpha motor neurons help cause the muscle to contract, while the gamma motor neurons help set the sensitivity of the stretch sensors so the muscle can stay coordinated. When there is damage to the upper motor neurons, the stretch sensors become more sensitive because of the gamma motor neurons. This causes the stretch reflex to occur too easily, leading to stiffness and the involuntary and muscle contractions. This is one of the key mechanisms behind spasticity. Thanks for sticking with us. That is all for this video. Here are some key takeaways. In the next video, we will be covering how multiple sclerosis damages upper motor neurons. Thank you for watching.